Hello, Business 270 online students. Professor Hassey. It's Saturday, October 1st, and this is our week 6 weekend update. I have posted the grades for paper number 2. Those grades are posted. Nice work by all. Also, my interpretation of the solution writing for the case or for the paper is posted to Blackboard as well. But every paper is different. Your own interpretations were taken into account. The only areas where we really had some problem is just in formatting of the APA paper. I took some points away if you didn't have reference section, even just saying you had no references, and also took some points away for not showing the course, the date, or the professor for which this work is based on. Besides that, a couple of points were taken away for some not providing enough detail in the analysis, but overall, those were the major areas in formatting. Everything else, the writing and the interpretation was fine, and I appreciate the efforts. You have another paper this week, paper 3, where you have to do some calculation and interpretation, and that is due October 2nd. So this week, our topic is hypothesis testing. And I want to show you one more video that kind of summarizes hypothesis testing, and that'll lead us into week 7 and our work with some problems and some analysis in regards to that. So let's take a look at this video.
Of hypothesis testing. It's one of the most central things that students study in all statistics courses, and it gives a lot of people problems. And I'm actually very excited to teach hypothesis testing because I believe I can break it down into bite-sized chunks so that as long as you follow me through lesson by lesson, you'll understand everything there is to know about hypothesis testing. The good news is it's not really a difficult concept to understand, but the bad news is most of the textbooks out there make it entirely too hard. The main reason hypothesis testing seems difficult to a lot of students is because there's a lot of different cases that you have to consider, and in those different cases you kind of have to handle it a little bit differently. So just take it from a bird's eye point of view. There's going to be some cases when we have small samples, and there's going to be some cases when we have larger samples. And there's going to be some cases when we're talking about this parameter and that parameter. And in those different cases, we're going to have to use different distributions, slightly different techniques to get there. But the overall idea of what a hypothesis test is the same for all of these kinds of problems. So what we're going to do now is go over some essential information. I could just read this stuff to you, but I'm going to write it on the board. It's going to take a little bit of time. Bear with me. You really need to understand every single thing. I have put nothing on here that's not important. So make sure you understand all of this. If you just take a few minutes with me here, then when we get to the problems, it'll seem so much simpler than anything you're going to read in your book. All right, so we have this thing called a hypothesis test. So let's talk about the idea of a hypothesis. Now, I know that everybody watching this has an idea of what they think a hypothesis is. I mean, we've all taken science classes. You kind of understand the basic idea of what a hypothesis is. But in statistics, there's a very specific thing that we're talking about when we say hypothesis. And basically, it's a premise, or a more common word is it's a claim that we want to test or to investigate. And the way we investigate things in statistics, we can't go into a laboratory and like do an experiment. But what we can do is we can go ask a survey of 100 people and get some data, or maybe 300 people and get some data. And we can use that to study the population. So when we talk about investigating a claim or testing a claim, what we're talking about is doing some sampling and getting that information and then testing the hypothesis. So much like in science, you have an idea and you want to test that. Maybe my hypothesis is if I go high enough up in the atmosphere, I'm going to get to a rainbow meadow with apples and the clouds. That's my hypothesis, right? Well, I have to test that somehow. Either I get a telescope, I try to look up there, or I try to build a ladder and I climb up there, or I get an airplane and I go up there. I need to investigate it somehow. In statistics, we're going to be coming up with a test that we want to perform to investigate some sort of hypothesis that we're putting together. So half the challenge is when you read the problem, you have to pick out the hypothesis from it, understand what they actually are interested in studying, and then you figure out the tests that you need to get there. All right, so that's a hypothesis. Now, we're going to talk about something called the null hypothesis. Now, what do you think the word null means? For those of you who have studied math or computer programming or something, null just generally means zero. Sometimes it can mean zero, something empty. But in general, when we're talking about the null hypothesis, what we're talking about is the default hypothesis, the thing that's kind of established, right? And so that's what we're basically talking about here. So when we're talking about the null hypothesis here, we denote that in statistics as H, that means hypothesis, with a small zero. The null or not, you might see it, is that's putting the zero there. What this is the currently accepted value for a parameter. So don't forget, though, what we're doing is we're investigating something. So when we're looking at a parameter of a population, maybe the mean of the IQ or something like that, we're going to have some currently established thing, typically, right? Maybe there's some previous studies out there that say that, the birth weight of humans is between this and this. That's the currently accepted thing. So we would typically call that H naught. That's the currently accepted hypothesis. But generally, some new guy comes along and wants to challenge that, and they believe that that's not true. So they come up with an alternative hypothesis that they want to test, okay? And we call that the alternative hypothesis. Now, the null hypothesis, the currently accepted thing, that's H naught. The alternative hypothesis, we call that H sub A because of alternative, okay? And this is also called, in some books, the research hypothesis. I'm going to put HYP for hypothesis, okay? And it involves the claim to be tested. So typically the way it goes, just think about science in general, right? So Newton, right? Isaac Newton comes up with a law of gravity. Apple falls on his head, comes up, invents calculus, invents the law of gravitation, right? So that would be kind of the currently accepted thing. But then a couple hundred years later, Einstein comes along and presents some alternative hypothesis that says, no, gravity really doesn't happen because of that. Gravity is really space-time and it's curvature, and let me show you. And so we're going to test this alternative hypothesis, and we're going to do lots of experiments. It turns out Einstein was right. Newton has a very simplified version of gravity that's not totally accurate, but Einstein's version of gravity is more complicated and it's much more accurate, and it's, as far as we can tell, really how the universe actually works. So there's always some null hypothesis, always something that everyone kind of considers to be true based on previous studies. Okay? But then some guy comes along and presents an alternative hypothesis. That's what you're trying to test. That's why it's called the research hypothesis, because that's what you're generally researching. So I might propose that the median income of people in this part of the country is higher than it was in the past. That's my proposal. So then I need to go test that somehow by doing some surveying. Okay? So H naught, H sub A. We're going to see those over and over again. H naught is the null hypothesis, and H sub A is the alternative hypothesis. So the easiest way to get you to understand this is for me to share with you. This isn't really a full-blown problem, but it's to get you to understand what the difference between H naught and HA is. So let's say it is believed that a candy machine makes chocolate bars that are an average of 5 grams in mass. A worker claims that the machine, after maintenance, no longer makes 5-gram bars. So here you have a manufacturing plant's been making chocolate bars for 10 years, right? They all come out, we believe, to be an average of 5 grams. But then some new worker is saying, wait, we've done maintenance on this, it doesn't seem to be behaving. I think that this machine is no longer making chocolate bars that are an average of 5 grams. So what would be the null hypothesis, and what would be the alternative or the research hypothesis? That's what we're trying to do. So the way you write this in terms of math is you write H naught. That tells the person reading that this is the null hypothesis. And you put a colon there, and then you say, well, the mean of the population of chocolate bars is 5 grams. This is the null hypothesis because it says right here, it is believed that a candy machine makes chocolate bars that are 5 grams. That establishes that that's sort of like the default position everybody always thinks. these machines are doing. But this person comes along and says, well, the alternative hypothesis that I'm proposing is that this machine no longer makes chocolate bars 5 grams. That's why I have not equals. So the null hypothesis is when people are believing that the machines make chocolate bars with an average value of 5 grams in mass. The alternative that I'm trying to investigate is that this machine no longer does this. I don't know if it's 4.9 grams or what, but statistically speaking, I don't think this machine is making bars an average of 5 grams anymore. This is my research or my alternative hypothesis. Okay? Important thing for you to realize, and you can kind of see it here, but I'll just spell it out for you. The null hypothesis and the alternative hypothesis are mathematical opposites. They're mathematical opposites, okay? And you can see that. This one says that it's equal to 5. This one's saying it's not equal to 5. For all of these hypothesis tests that we're going to do in this class, the null and alternative hypothesis, they're always going to be opposites of one another, mathematical. In some cases, we'll have less than arrow sign here for the null. Well, then that means the alternative has to be greater than, because basically the alternative is going to be whatever the null hypothesis is not. That's just the way it always is for every problem. We're going to do so many of these problems. You'll get to see it over and over again. Here, it's very easy to see that these are mathematical opposites. All right? So let me ask you a question. Let's say that this was actually our conundrum. We were running a chocolate factory. The null hypothesis, we think our machines were running and making 5 gram bars, but now a new maintenance guy says, hey, we've done an overhaul, and now the chocolate bars are no longer 5 grams. So what are the possible outcomes of this test? We want to test the alternative hypothesis. So this guy is thought to be true. It's kind of like a court. You're innocent until proven guilty. So we're going to assume that the null hypothesis is still true, unless the evidence says that we need to reject that null hypothesis, in which case this thing we say to be is true. So it's kind of like an uphill battle, just like anything in science. You have the currently accepted thing, and then you have a hypothesis. Well, you're always going to assume that the null hypothesis is true unless evidence points otherwise. So what are the possible outcomes of this test? The possible outcomes of this test, and when I say this test, I mean this investigation of the alternative hypothesis. There's only 2 things that can happen, and they're phrased very specifically in statistics. Okay? The first thing that can happen is that we can reject the null hypothesis. Okay? If we reject the null hypothesis, then we say the data says this is no longer true, in which case this guy is promoted to be what we think is. We're not really proving it's true. We're just saying the evidence is saying this is false. Therefore, this must have more truth than the null hypothesis. The other thing we can do is we can fail to reject it. Null hypothesis, H naught. Notice that we've never proven that the null hypothesis is true. It's very, very hard in life to prove that something's true. How do I prove to you that the sun is true? Well, have you ever touched the sun? Well, you can see it, sure, but it could be a movie projection, it could be anything. It's very hard to prove something's true because we can't always go out and touch everything, okay? So we're not really proving that one of these is true and one of these is false because it's very hard to prove it's true. It's just like a court of law. You assume something is true, and you're trying to basically prove and see if you reject a premise or not. So here, there's 2 possible outcomes. We reject the null hypothesis, or we fail to reject the null hypothesis. If we fail to reject the null hypothesis, then we're basically keeping our arrow here and we're saying we believe this to be the case. If we reject this guy, then we come down here and we say we believe this to be the case for the currently accepted data that we have. We're not really proving it's true, we're just saying this is false or this is not false. And then whatever else is around is going to be promoted to the king of the hill, so to speak. And that's then at that point forward, I guess you say you believe that that's true until something else challenges it. So you either reject the null hypothesis or you fail to reject the null hypothesis. All right, so the question then becomes, how do you do the testing? How do you actually determine if you reject it or not? Well, you have to use something called a test statistic. Right, the test statistic. And what this means is this is calculated from sample data. and used to decide. And what are we deciding? We're just trying to decide if we reject the null hypothesis or we fail to reject the null hypothesis. So, as an example, in this case of the candy bar factory, I'll just put like a big example here because this is not a real example, but we're kind of getting our feet wet. Maybe we sample 50 bars, 50 chocolate bars. Obviously, we can't sample all of the bars because we're trying to sell chocolate. We can't open them all, right? So we just sample 50 of them because it's not practical to do it to all of them. Let's say that we get average value of the mass of the bar, right? Then we calculate, we use this information, something that we call the test statistic. This is basically an equation that's dependent on the type of problem that you have. And you use this test statistic to help you determine, is the data that you have statistically significant enough to reject this null hypothesis or not? So just to kind of give you something a little more concrete, I used this word just a second ago, but we talked about the thing called statistically significant. In layman's terms, what is statistically significant in terms of a hypothesis test? What it basically is where do we draw the line to help us decide if we should reject the null hypothesis or not, to make a decision? Question mark. Okay, so to kind of put it into concrete terms, we have this candy bar factory. The null hypothesis was always accepted that we made 5-gram bars, but we did an overhaul, and now some guy's claiming that we no longer make 5-gram bars. So how would you do this in real life? I mean, think about it. What would you do if you were the maintenance guy? Well, you go grab some candy bars off the conveyor belt, and you would go and find their mass, and you would figure out if they're 5 or if they're not 5. So let's go through that kind of little thought experiment and see what would you get. Let's say one guy does it on Monday and gets an average value, and let's say we draw 50 of these bars, right? 50 bars. And let's say we get 5.12 grams, okay? Well, that's not exactly 5 grams. So technically, it's not equal to 5, but it's awfully close to 5. So how much play did our original equipment have to begin with, right? Now, what if a different guy does it on Wednesday and samples 50 bars, and he gets 5.72 grams. Now this is no longer close to 5. This is closer to 6 grams. So I'm starting to feel uncomfortable that this null hypothesis is true. I'm thinking about maybe I should reject it. And what if one guy on Friday takes 50 bars and gets an average of 7.23 grams? Now this is so far away from 5 grams, and I'm almost confident that if I get this data here, the machinery is definitely not behaving normally. In that case, I'd probably reject the null hypothesis. I'd probably say, we're no longer making candy bars that have an average of 5 grams. Why? Because I sample 50 bars. That's not just 1 or 2, that's 50 of them. And I believe that this number, 7.23, is what we call statistically significant. It means I've sampled so many of them that I'm pretty darn sure that it's not a fluke. And I think that this is so far away from 5 that there is no way that this null hypothesis can be true. Therefore, I reject that null hypothesis. So it's easy to see whenever you have an answer like 7.23 grams, that's really far away. Everybody would probably agree the machinery is malfunctioning. But I think some people, if you look at this number, might think, well, it was only 50 bars you looked at. Maybe we should look at more. It's kind of far away from 5, but it's not that far away. And I think a lot of people would look at this number and say, that's pretty darn close to 5. I mean, man, we should look at it again, investigate it, but I'm feeling pretty good that our machine's behaving, at least okay. But still, all of those cases, they're very subjective. They're very fuzzy. Like some people might say this is okay, some people might say this is okay, most people probably would say this is not okay, but there's no concreteness in any of that. We're all just talking here. I'm kind of explaining to you here. Statistics is not about just your whim and how do you think it should be. We have to have a concrete way of looking at this null hypothesis, collecting our data, and having a concrete way to decide when we reject the null hypothesis and when we leave it there. When we say that we fail to reject it, and then therefore we think it's still true. We have to have a concrete way of doing that. That is what a hypothesis test does. A hypothesis test collects the data, puts it in an equation, you get a number back, and that number, we're going to show you how to decide when that test statistic is too high or too low, and when you reject that null hypothesis and when you don't. So you don't have to guess. You look, you calculate, and you decide based on concrete boundaries, basically, is what you do. All right, so let me go off to the next page, and let me rewrite something that I know that you've seen before in the previous sections, but I want to just write it again here. We've talked about this a lot before, but the level of confidence. We've done this, obviously, with confidence intervals. It's exactly the same thing. The variable is what we call C. And you might say that C is 95% or maybe 99%. Now, of course, when we use C in calculations, we use the decimal form, 0.95 or 0.99. But basically what it is how confident are we in our decision. In other words, don't forget we're doing a test. We're doing a hypothesis test. We're testing something and we're deciding to reject the null hypothesis or to fail to reject the null hypothesis. The level of confidence is telling us how sure we are that we've made the right thing. If we do a hypothesis test at 99% confidence, then we're 99%, and we decide to, let's say, reject that null hypothesis, then we're 99% sure with certainty that rejecting the null hypothesis was the correct thing to do. But if we only have a level of confidence of like 50%, who's going to believe you? I mean, if you're only 50% sure that you're doing it right, nobody's going to believe that information. So you always are going to see a level of confidence up around 90, 95, maybe even 98, 99%. Okay? And then we have the complement of this, which we call the level of significance. And I've covered this a lot in confidence intervals, but I'm writing it here because I just want to make sure everybody has it in one place. Basically, we call that alpha, and that's 1 minus the level of confidence. So, if the level of confidence is 95%, right, then that means that C is 0.95. And in that case, if the level of confidence was that, then alpha would be 1 minus 0.95. So alpha would be 0.05. So you see, C plus alpha always add up to 1. And that's just because of the relation we have here. So C and alpha really specify the same thing. Level of confidence, level of significance. Some problems will specify the level of confidence. Some problems will specify the level of significance, but they're both telling you the same thing. How sure are you that you're making the right decision or not? All right, so I don't want to write anything else on the board, but I just want to reiterate everything that we've talked about, and then I'll close with an analogy, okay? In statistics, we want to test a hypothesis. A hypothesis is just some claim that we want to investigate, and there's two types. The null hypothesis is what we currently think is kind of fact or true. Usually it comes from a previous survey or a previous set of data, something that somebody's done in the past. Along comes somebody else with new information and proposes an alternative hypothesis that they believe is true, but this is what we need to investigate or test. H naught is what we currently think is true. H alpha is what we're proposing to be true, and this is what we're essentially testing. And these are mathematical opposites of one another. So the only way that we can resolve this is either we reject the null hypothesis or we fail to reject. If we reject this guy, then we're promoting this and we're believing this to be true. If we fail to reject this guy, that means that we're saying we're not rejecting it, so we continue to believe this is true. And the analogy I want to draw to you, I've kind of hinted about it a little bit, but I want to make sure you understand that it's very similar to how courts work here in the United States, right? When you are accused of a crime, you're presumed to be innocent. That's the way it's supposed to work anyway. So whenever someone is prosecuting you for theft or something like that, then the court is going to assume that you are innocent. And it's up to the lawyers and the evidence to prove your guilt, okay? If you can't prove that, then we must go back to the default or the null hypothesis, which is that you're innocent. And it's the same kind of thing here. We presume that this is the case unless the evidence tells us to reject it, in which case we go down to the next hypothesis and we say we think that is true. Okay? You don't have to prove innocence in statistics. And when I say innocence, I mean you don't have to prove the null hypothesis is true. You're just assuming it is. and either you reject it or you fail to reject it. So here was a lot of definitions, a lot of groundwork, but I promise you that by understanding this stuff, when we get to the next section, it's going to be much, much easier because you'll know what a null hypothesis is, and you'll know what an alternative hypothesis is, and you'll know the general idea of what we're doing with hypothesis testing. All right, so let's go on to the next section. We'll learn how to write these hypotheses down. I'll show you how to figure out the test statistic and figure out when do you decide to reject or fail to reject, and it's going to be based on numbers. It's not going to be based on what I think it should be. It's going to be based on numbers, and that's how we do it in math, is we use numbers. So follow me on to the next section. We'll get some practice with hypothesis testing in statistics.
Okay, that was just some definitions of hypothesis testing that I thought would be benefit to us to learn or to review. And then next week, as the instructor says, but I'll be doing it, we'll look at some problems and some examples of hypothesis testing and this statistical testing and confidence levels with some hard numbers next week so you can get a feel of how all that works. In other words, though, we're just using statistics to test out theory, to test out what we think is going on compared to what somebody else might think is going on. And we test that who's right. And that's what we're doing there. All right, just going back briefly to our Blackboard, we in the case study and papers file folder, there is the solution to paper 2. Paper 3 is due this week. This is our last paper of this fall session. We have 2 weeks to go next week, week 7 and then week 8. Week 7, the only graded work will be some discussion forum posting. Very briefly, 1 or 2 paragraphs by each student about the topic that we're talking about, hypothesis testing, and that'll be a discussion forum posting next week. And then in week 8, we have our final examination, which will be a series of problems and questions about our review this week. And I will have next week, in week 7, I will have a final examination review document to be posted, which will just give a brief outline of what that examination will cover. So that's where we are. So again, check your grades in your grade center and your report card to make sure you're up to date. Again, some students do have some holes. They're either they're late in getting their extensions in or something else has happened. So make sure you have communicated with me your status about some of those grades. And remember, we only have 2 weeks left. We have paper 3 grade this week, and then the 5 percentage point discussion forum next week, and then the 25, I believe, per point examination grade in week 8. So make sure you have a handle on where you stand with your grade average and you understand it. Okay, that's it for this weekend update. Again, paper 3 is due Sunday night at midnight. I'm looking for an analysis of the croissant bakery and what is the difference between a random variable and a probability distribution. Is this analysis discrete or continuous? And what does the data tell you about the quality of the analysis? I give you the mean of being the number of cakes sold over a 5-day period of being 13.2. I'm asking you to determine the variance and the standard deviation of that variance. And what does that standard deviation tell you about the quality of the analysis? All right, everybody, have a great weekend, and we'll talk to you again next week. Adios.